I'm just going to review lesson 7.1. We did it before the break. I think Thursday before the break, and then Fridays when we have the Pi Day celebration. So I'm just going to go over this, give you the assignment again in case anyone was absent. The first theorem is polygon interior angle theorem. And it says the sum of the measures of the interior angles of a convex polygon, or n-gon, is n minus 2 times 180. All right, so we're going to be using that formula a lot. And n is for the number of sides. So like for this example over here, this is a 6-sided figure. So we would do 6 minus 2, whatever that is, we would multiply it by 180. 6 minus 2 is 4. So we would take 4 times 180, which is 720 degrees. So the sum of the measures of the angles, if it's a 6-sided figure, is 720 degrees. Okay? Move on to the next one. Okay, on this one it says, find the sum of the measures of the interior angles of this figure. So first we have to figure out how many sides it has. So if you count the sides, so we have 1, 2, 3, 4, 5, 6, 7, 8. So if it's an 8-sided figure, you put it into that formula, n minus 2 times 180. Okay, n is the number of sides. Excuse me, which is 8. So it's 8 minus 2 times 180, which is 6 times 180. If you multiply 6 times 180, you get 1,080 degrees. So if I added all the angles up on this 8-sided figure, I would get 1,080 degrees. Okay, another one. All right, this says the coin shown is in the shape of an 11-gon. Find the sum of the measures of the interior angles. All right, so if I put that into my formula, you do the number of sides minus 2, and you multiply that by 180. 11 minus 2 is 9. If I take 9 times 180, I get 1,620 degrees. Okay? So there's just several problems where that's all you're doing is plugging it in. And then we get to these where they're going to give me the sum, and I have to use that formula to work backwards and figure out how many sides it had to start with. So this one says the sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. All right, so I know what the sum is. I'm going to work backwards and find the sides. So I'm still using that formula, but I know what the answer is. It's 900. Okay, so they told me that. So what would you do first to solve for n? Okay, you would divide by 180. So if you do 900 divided by 180, you get 5. And then your last step is to add the 2 over, so you get n is 7. All right, so after you find the number of sides, it says classify. That means they want you to name it. So you'll have to remember those names, and I'll go through those in just a second. I'll remind you of some of them. So a 7-sided figure, you can either name it as a heptagon or septagon. Right, either one of those would be your answer there. So just a reminder here. So I think we all know what a 3-sided figure is. If you, but I'll do it anyway. So it has 3 sides. it's a triangle. Alright, 4 sides is quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 we just did, so it'd be septagon or heptagon. Either one's fine. And 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11, I'm sure there's another name for it, but the book just says 11gon. Anything they don't have a fancy name for, you can just put the number and then dash gon. 12-sided, we have a name for that. It's dodecagon. And anything over 12, they don't expect you to know that. So like 13, you just put 13 gon. Alright. Okay, so use those on your assignment. Go to the next page. So we have a corollary, which is like, by the way, you all need to know this. It says the sum of the measures of the interior angles of a quadrilateral is 360. All right, quadrilateral, 4 sides. We could have used the formula and get it, so you don't really have to remember that. It just makes it kind of easy if you do. So 4 minus 2 is 2. Take 2 times 360. I'm sorry, it's not 360. I just wrote the formula down, right? 180. So 4 minus 2 is 2. 2 times 180 is 360. So you could have gotten it with the formula, or you can just remember that 4-sided figures have a sum of 360. Alright, which makes these problems easier. So if I want to find x in this problem, I would add, right, the 3 that they gave me together and subtract from 360 to find the 4th one. So if I add all 3 of those together, I got 288 degrees. So I'm going to take 360 minus 288, and I end up with 72 degrees. So x would be 72 degrees. Okay. Let's look at this one, number 2. So again, this is giving me the sum, and they're asking me to work backwards to find the sides. So it says the sum of the measures of the interior angles of a convex polygon is 1,440 degrees. Classify the polygon by the number of sides. So using the formula, I'm going to have n minus 2 times 180 equals 1,440 degrees. So again, you want to divide by 180, get rid of that, and so I get n minus 2 equals 8, and then add the 2 over, n is equal to 10. So you have to classify it, which means, don't forget that part, it's not just 10, you have to name it. And a 10-sided figure is a decagon. So decagon is your actual answer there. Okay, let's look at this next one. Excuse me. It says the measures of the interior angles of a quadrilateral are x, 3x, 5x, and 7x. Find the measures of all the interior angles. Alright, so it's a quadrilateral, so we know that they all add up to 360, right, because we have that corollary. So if I add these sides up, so x plus 3x is 4x, plus 5x is 9x, plus 7x is 16x. So if I add all 4 sides up, I get 16x is equal to 360. So I divide by 16, and I get x is 22.5 degrees. Okay, it wants all of them, right? So I have to plug that in. So x is 22.5 degrees. The next one they wanted me was 3x. So I take 22.5 times 3, and I get 67.5 degrees. All right, the next one was 5x, right? So take 22.5 times 5. That one's 112.5 degrees. And the last one was 7x, which I take 22.5 times 7. I get 157.5 degrees. All right, so all four of these you need. And to double check yourself, you could add them all up again, and it should add up to 360 because it's quadrilateral. Okay. Let's see, we're getting close. Not too many more. All right, it says a home plate for a baseball field is shown. Is the polygon a regular polygon? Explain your reasoning. All right, in order to be regular, it has to have equal sides and equal angles. Okay, so for example, a square is a regular quadrilateral because all four sides are equal and all four angles are 90 degrees. Okay, so a square is a regular quadrilateral. All right, so looking at this, it's 5 sides. Are all 5 sides equal? I don't know. It doesn't look like it to me. Are all 4 angles equal? No. All right, these 3 are, right? Those are equal to each other, and these 2 are equal to each other, but they're not all 5 equal to each other. So this would be no. And you could just say angles are not equal. Okay? And then on part B, they want us to find angle C and angle E. Right? So I know what these 3 are, right? A, B, and D are all 90 degrees. How can I figure out what all 5 of them should be? What formula do I need to use for that? This one? Okay, so first you want to figure out what all 5 of them should add up to. So you do 5 minus 2, which is 3. Multiply that by 180. And 3 times 180 is 540 degrees. So all 5 of them should add up to 540 degrees. I know what 3 of them are. They're 90, right? So 3 times 90 is 270. I'm going to subtract that. And 540 minus 270 is 270. So I have 270 degrees left to divide equally between E and C, because E and C are equal. You can't tell because I drew all over that, but yeah, E and C are the same. So if 270 degrees split equally means I'm going to divide it by 2. 270 divided by 2 is 135 degrees. So both angles are 135 degrees. Okay, next page. So this is the last theorem in this section, 7.1. It says the polygon exterior angle theorem. The sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. All right, so the sum of the outside angles is 360 degrees, regardless of how many angles there are. So there's 5 angles there, they still all add up to 360 degrees. So that's what you need to remember, is the sum of the exterior angles is 360 degrees. Okay? So let's look at this. So it says find the value of x in the diagram. So I know that they all add up, because they're exterior angles, right? I know they add up to 360 degrees. I can add these to 89 plus 67, and that is 156, right? And 2x plus x, I can add those two, that's 3x. So I can make an equation that 3x plus 156 equals 360 degrees. So that's all four angles. This is 2x plus x, this is 89 plus 67. So then I can solve for x. So I would subtract 156. So I get 3x equals 204. And then divide by 3. And I get x is equal to 68 degrees. Alright, and in the directions they just wanted you to find the value of x, so you don't have to plug it back in to find the other angle. So outside angles add up to 360 every time. Alright, same thing on this one. So it says the trampoline shown is shaped like a regular dodecagon. Alright, so dodecagon has 12 sides. Regular means that they're all equal, right? And so are all the angles. It says find the measure of each interior angle. Okay, so to do that, we could find out what the sum is by using that formula, right? Which is n minus 2 times 180. I plug that in there, so 12 minus 2 is 10. And I would get 1800. Alright, so that's how much all 12 of them should add up to on the inside. So the sum of the interior angles is 1800. Okay, since it's regular, then all of those angles are equal. So to find one of them, I would divide this by 12. This only works if they're regular, which it said it was. So if I take 1800 divided by 12, I get 150 degrees. Okay, so the interior angles are 150 degrees each, and there's 12 of them. And the next one says find the measure of each exterior angle. So there's also 12 of those, and I know that the exterior angles always add up to 360. So if I take 360 divided by 12, I end up with 30 degrees. Okay, and then what do you notice about the exterior and the interior angles? 150 and 30. Okay, they add up to 180, or they're supplementary. So if I know one of them, I can find the other one by subtracting it from 180. So you'll need to know that for your assignment. So make sure you remember that. Okay. So this is the last example, number 6. Says a convex hexagon has exterior angles with the measures of 34, 49, 58, 67, and 75. What is the measure of an exterior angle at the 6th vertex? Okay, so if it's a hexagon, it has 6 sides, right? We know that the exterior angles always add up to 360. And they gave me 5 of them, right? So I would add those 5 up, and I would subtract that from 360 to find the 6th one, and those add up to 283 degrees. Okay, so all 5 of those, if I add those 5 up, I got 283 degrees. And I subtract that from 360, and that gives me that the last angle, the 6th one, has to be 77 degrees. Okay? Alright, 7 says an interior angle and an adjacent exterior angle of a polygon form a linear pair. Okay, linear pair means they add up to 180. They're supplementary. Okay, how can you use this fact as another method to find the measure of each exterior angle in example 6? So in example 6, if you knew the exterior angles, you could subtract from 180 to find the interior, or vice versa. All right, so that's what we talked about earlier, that they're supplementary, so you can use it for that. Okay. And that's it. So if you haven't done this assignment, this is what we're going to talk about on Monday, and that would be 364, 4 through 32, even, and then number 38,